in this episode of Finnogric Machining, well, we are going to do something for the sailboat. This is the plan, and then I have material there. It's the food for the mast. And if you wonder my speech, well, this is the first time I'm really wearing my dentures. Well, they say that you get used to them, maybe, but if you don't wear them, there is no possibility that you get used to them. So I wear them. Sorry about my speech. Okay, let's go on with this thing. Well, this mast base consists of three stainless steel tubes, which are arranged which are set up like this. In the middle there will be the mast. There will be a 25 millimeter in diameter pin going into there, and there will be something to take the weight of the mast in the bottom. And then there will be holes for rigging, wheels like this. These wheels one can buy very cheaply. These are like 3 euros piece, and they are horrific. You probably can see if I go there. Considering that this is going to receive, there will be a rope going through here, and then it's going up there, and the pull on the rope will be several hundred kilograms, maybe 1 ton, and then this kind of wheel, which is they rate these somewhere around 1 ton, but it's a poor execution. Waste of good material. That's my waste of good material. Okay, now these steel tubes had a seam inside there, and this seam I have already cleaned this and this, so we still have one left to go. The tube itself is wait a minute, it's 40 millimeters by 40 millimeters, and the wall thickness is 3 millimeters. So this should be, all the burrs should be away before I start machining these. I really don't, and especially the seam here inside, it's very noticeable. It's really bad. So, but it can be taken off by a file. And these dentists, these false teeth are really false. I don't get used to them. Okay, so now I start filing this. It's not really beautiful, but it's better than it was. So this is now attached to the milling table, and it's also dialed so that it's straight. Yeah. And now I'm going to make, and please note that the seam is on the top. It should be. Okay. And now I'm going to make some markings here. just to sanity check this when I dial this in. So this is 200 millimeters long, and the hole should be in the center. So 100 millimeters about, and this is not exact. There it is, about 100 millimeters. And then we have this 40 millimeters wide, so I put a marking around 20 millimeters, like there. That's my sanity center. When I really dial this in, I can see that it's on the ballpark of that one. The real dialing is done by, well, Edge Finder. Well, this is probably too precise for this thing, but well, yeah. It doesn't hurt if it is quite precisely there. So, well, this is a starred Edge Finder with 10 millimeter shank metric, and 6 millimeter touching surface. So there you go. Doesn't need to be really tight, just so that it is there. And now I will also use a little bit more speed when I use it. Cannot be on the back here. Sorry about my blocking your view. Switch the machine on, and let's go. I will first dial in the X and about in the middle like that. Let's see the speed. Well, it's enough. This chord scale I put it on 10. This one is the automatic stopper. This one is the scale on 10. Wow. So actually not 10 because well, this is now 3 millimeters away from the okay, so I would like to get it here, and then 3 millimeters. Man. So 1, 2, and 3. There. Now the center of this spindle is at the edge of this. Moved really 3 millimeters here as well. There you are. That's now in place. So now I can easily move like 10 centimeters here. No problem at all. So let's move. And then I check from the 0 here. It should be 0. Now it's 21 millimeters. Why? Yeah, of course, because I didn't zero the scale. Yeah. That's the X. We don't move it anymore, so I lock it completely. This table has 2 locks, which when you engage both of them, it's really solid. So now, next is the Y. It's 20 millimeters we go. So 4 turns, 1, 2, 3, 4, and then 3 millimeters for that thing. So there, and lock it. And we are not in the correct place, not at all. I can tell. Why? Because I didn't do it correctly, I believe. So let's go back. Do this again. Okay. That's the edge. So it's 5 turns. 1, 2, 3, 4, 5. 5 times 4 is 20. Plus 3 millimeters for the edge detector. And now, yeah, now the sanity check and this one matches. It's really important that you use put a sanity check there, so you can immediately see if something is wrong. It's so easy to miscalculate things and so on. So yeah, for me at least it is. So now we can get rid of this thing. Well, then we just drill a hole. Now a 7 millimeter hole. Well, this is just to avoid. This is a split point drill, and the speed at the moment is 90 revolutions. No, 420 revolutions per minute. So, and I'm feeding by hand. Oh yeah, this is stainless. You don't hesitate with stainless. If you do, you will spoil your drill. Okay, and now 13 millimeters, and this time I'm using feed. It's 17 millimeters per minute, and the drill is spinning considerably slower. It's 19 revolutions per minute. So let's go. Hopefully this works. The drill is not in the best possible condition, but yeah, this works. Yeah, it's true. Well, it's only 3 millimeters thick. Okay. Oh yeah, and these chips are really horrific. Thick, really thick and stout. Well, yeah, I put the cutting oil here on top of the flutes, and then it just runs down into the drill where it is really needed. I first try this by hand. Let's see how it goes. Well, this is a sharp drill. I'm feeding really slow with this, trying to avoid rubbing it. This goes nicely. So far. You have to feed it continuously. Otherwise, if it rubs, the game is over. Oh yeah. I'll take it back a little bit. Put some more of this stuff there. Maybe there. And then we go on. Okay, now there. Well, it's whining. We are through. Yeah, a little bit more so it takes care of the burr. Oh yeah. Again, quite heavy chips. Those are sharp. Careful. this quadratic workpiece into a round workpiece with a diameter of 30 millimeters. aligning this bronze piece so that I can dig. Well, it's a round hole. Around it, I don't know, concave, convex. I never know which one is the correct word, but let's say it's concave because it's a little bit like a cave. So concave, which has a diameter of the is 70, so 35 millimeters radius. So first I will align this at the end of this surface. There you are. And by the way, this is by no means exact. This 70 millimeter diameter is just a ballpark. So, well, but I present here a method how you can make it really exact. So now we have it there. Now the axle of this spindle is 3 millimeters away from that surface. And now I lock the table a little bit because I need to take care of some backslash here. Like that. And then 35 millimeters. Let's take away those 3 millimeters first. No, we already have. So 32 millimeters from that place. I need to do this again. Yeah, the backslash was correct. So now 32 millimeters from that point I put my scale on 20 here, so that I know 32. 10, 20, 30 and then 2 should be there. Yeah. So that's actually now the spindle center is 35 millimeters away from that surface. Now I'll change a cutter here. This here is our cutter. I ground this, as you can see, it's a little bit round and it's super sharp. So, well, let's see now. It's like a fly cutter, but it doesn't have any angles. It's just straight, perpendicular, the blade. I have made this holder a while ago, and okay. Oh, it's a little bit loose. Let's put it in back here so I can tighten this. Oh yeah. There you are. Yeah. And now the 3 here. With these 3 screws you can tighten it into place. I put it just a little bit like, not really tight, but so that it doesn't drop. And let's see now. Oh yeah, okay. Let's go a little bit down, like that. So now I push it against, oh, I push it against. Yeah, this is really okay, now let's see. Okay. Pull it a little bit more from there. And then when I turn it like this, it adjusts the blade automatically into place. And now I just tighten it there. Now the radius is correct. Next step is to center it. Well, wow. And this again is not very, doesn't need to be that accurate. In my case it's okay. I think we are there. Okay, maybe, maybe. Well, let's lock the X. No, not the X. Well, yeah, but the Y. Okay, and now what I'm going to do, I'm going to run it and then do, I don't know how deep cuts, but let's see how this goes. So let's take it out and see how it looks like. Wow. It's really nice. Yeah, so there will be a similar radius on the top of a pin that goes into a hole there. And yeah, and this will be sitting down there and taking, there will be about 2 tons of force into this piece. And well, hopefully it all can hold that. I believe it can. Well, it's not entirely round, it has some but that was because it was not in the absolute center. So now, okay. But there you are. The last step for all of these 3 is to drill holes and ream holes for a pin that goes through. And well, this pin is taking care of, it's like a shaft for these things. There will be a rope going through here from this side, and then it goes up. Well, up is this direction, goes up, and then, yeah, well, as simple as that. Well, this is a 9.9 millimeter drill, and sorry about my funny speech. it's a 9.9 millimeter drill, and I will ream the hole to exact, well, H7 exact hole to accommodate the pin. Yeah, there we go. I let it first drill just a little bit and then I push it through. This is again stainless steel, so no hesitation here. That would be bad. Now reaming these 9.9 millimeter holes to 10 millimeters. Well, easy enough. I have here a 10 millimeter H7 reamer. Well, just go, and the thing is that you don't want to run this fast, and there is very little to come off from this. Only like 0.1 millimeter, so it's, and there you are. That was the first one. And I will do these locating holes first. Which side was it? Was it this side? Yeah. Okay. And now how I align this. I just push this. Let's assume it's a little bit on the side, and when I push it, it will eventually center itself into the hole. There you go. And the last locating hole. There is a small taper at the tip of this reamer, so I use that one for locating it in the workpiece into place. Now it should be there. I can. Can I? Okay. Oh, that's tight. That's really, really tight. Okay, now it's there. like that. Okay, and then I can put this like this. That one too. Now it is there as I wanted it to be. It's there in the middle, so it locates them from that end. And now what I want to do is to put this through the center one. With this I only ensure that it stays flat when I do my thing. Well, this can flex quite a lot, but this end doesn't. I don't know how tight I should make this. Like that, maybe. Yeah. And now I should ream this like all the way through. Somehow I don't like the setup. But that's the only way we can do this. And yeah, okay. Let's go. Number 1. Number 2, and there is also number 3 going right from there. Okay, that side is now done. And then the other side. It will be... I wish I could have done it like... Well, it reaches to the... of course I do it as far as I can do with this setup. Of course. I do. Let's put it into the hole. Because I can do the other one as well there down. And that should be okay now. Let's see. Not that. That should go easily. Goes easily. And now we have one double hole there. Yeah. Okay. That's the last one. Yeah. There you go. And then I can loosen this one and take it away. This should go without any trouble. Should! Oh yeah. Oh yeah. And now we are in that place that was a little bit. There you are. Okay. Well, those parts are now ready. The pins, the 3 long pins, I don't do them today because I don't have the material. It's on the way. It will be stainless, and therefore I have this mild steel, but in the sea, in a sailboat, so it must be stainless. There is no other way. Okay, so that will I probably will show some of that in the next episode of Finnogruk Machining, but well, till then. Bye!